Alright everyone, we're going to talk about two special right triangles. These are the most special right triangles, and we're going to talk about why are they special. Okay, well first, this is a 45-45-90 triangle. If I had drawn this properly, these would be exactly the same. These two sides would look exactly the same. There's a reason for that. Why that is this comes from a square. Now, if you watch my videos on origami, you'll notice that a square is actually a perfect shape for a piece of origami paper. That's exactly all origami papers are that size. And half of a square, if we cut that in half along the diagonal, you get this. So you get, what happens is, if a square has four 90-degree angles, when you cut it in half, you get a 45 and a 45. So that's where you get the 45-45-90 triangle. And then if the bottom side is 10, then this side has to be 10. Or if this is 6 inches, this one's got to be 6 inches. So the two sides are always the same. The third side is something different. Let's talk about that. We can choose any number we want, like 10 and 10, 5 and 5. These are both supposed to be the same. X and X. Let's make them 1 and 1. So what's the third side? Well, if this is a right triangle, and it is, then the Pythagorean Theorem works. So we can call that A, and this B, and this is C. We can say 1 squared plus 1 squared equals C squared. We've seen the Pythagorean Theorem now. All right. And where we go from there is 1 plus 1. Well, 1 squared is 1, plus 1 squared is 1 equals C squared. That's 2 equals C squared. Now, don't stop there. You are not done. What it is we want just C. So we're going to square root and square root. Square root of C squared is C. Square root of 2 is irrational. So we'll leave it like that. All right, there you go. So this always has this ratio, 1, 1, square root of 2. That's the special ratio, or relationship, shall we say. Now this triangle here comes from somewhere else, and it's also very special. And it goes like this, 1, 2, 3, but it's rad 3. 1, 2, rad 3. Now, how the heck are you going to memorize that? Well, that's what I'm going to show you right now. So the 30, 60, 90, it's always like this. The short side is the 1, the long side is the 2, the weird side is the rad 3. Now, why is that so useful? Well, where it comes from is if you had a perfect equilateral triangle, if I made all these sides exactly the same, that's why I'm using my old ID card for this. There you go. All right. If these are all exactly the same, then let's see if we can agree on some stuff. All right. These sides are all the same. We can call them 10, 10, 10, 5, 5, 5, 3, 3, 3, whatever you want. So, for easiness, I'm going to put 2, 2, 2. All right. If you're okay with that being 2, 2, 2, then you should also be okay with me saying, okay, I'm going to split the middle of this triangle. All right. Well, if I went right down the middle, can you agree? Can we agree that it'd be 1 and 1, because we split 2 into half. So it's 1, 1 and 1. Okay. The other thing is I went straight down the middle. So if these angles were 60, 60, and 60, which they were, because it was an equilateral triangle, and I went right down the middle, well, what's the split of 60? That's got to be 30 and 30. Aha! So we split the middle angle, and it's now 30 and 30. Well, if we have 30 and we have 60, there's only one possibility. That last angle has to be 90. So, let's redraw that. Oops. So there's your triangle. We redrew it down here. Okay, because we don't need both of them. We just need one of them. Now, we have a missing side here. Now, we're going to use the Pythagorean Theorem again, but here's the deal. This is now our longest side, so that's got to be our C. Let's call this A and let's call this B. Then we go 1 squared plus B squared equals 2 squared. A squared plus B squared equals C squared. That is 1 plus B squared equals 4. And if we subtract 1 from both sides, we get B squared equals, B squared equals 3. We don't want B squared. We want B. So we now have to go like this. Square root and square root. Now, square root and square root cancel. B itself is square root of 3. So that's where we get this weird square root of 3 from. Okay, so you can memorize the triangles, and your teacher probably will ask you to do that next year, or definitely by the time you get to math analysis. Or just remember, it's a 1, 2, 3 triangle. 1, 2, rad 3. Or know that you can get it from splitting the original triangle. Go 2, 2, 2, and split it. The main thing is to know the long side is 2, the short side's 1. So the short side's got to be across from the 30. That's it. There's the 1, there's the rad 3, and there's the long side. All right, so make sure, practice that, study it, know that you could draw it anytime you need it on any quiz. By starting with that, 2, 2, 2, split it and see what happens. Well, then this has to be 1 and 1. And then the only thing that's left is rad 3. But you can get that from the Pythagorean Theorem. All right, thanks for watching.